Hello, this is Mr. Collier, and today we're going to do a couple more proofs by induction. Okay, so in this example, we're going to prove that the sum of the cube numbers from 1 to n equals n squared times n plus 1 squared out of 4. So we're going to start with our n equals 1 and show that that's true for n equals 1. So if n equals 1, then you sum up the cubes, it's just going to be 1 cubed. And that equals 1, of course. And also, if we have n squared times n plus 1 squared out of 4, that's going to be, in this case, 1 squared times 1 plus 1 squared out of 4, which equals, that's right, that's correct, which equals 1 times 4 out of 4, which equals 1. So it's true for n equals 1. Now we're going to assume it's true for n equals k, for some k greater than or equal to 1. Okay, so that means that 1 cubed plus 2 cubed plus, and so on, up to k cubed equals k squared times k plus 1 squared out of 4. And lastly, we're going to show it's true for n equals k plus 1. Alrighty, so we're going to start off with this 1 cubed plus 2 cubed plus k cubed, and the last one is going to be k plus 1 cubed. And we're going to, actually right now we can do a substitution right away. All this up to k cubed is equal to this expression. So we're going to substitute that in. So that's k squared times k plus 1 squared out of 4. And for this bit here, we can write this as out of 4 as follows. So we can write this as 4 times k plus 1 cubed out of 4. Okay, so next we're going to add this together. Actually, before we do that, let's show what it should be equal to, what we're aiming for. We want to show that this is going to be equal to, if we use k plus 1 here, it would be k plus 1 squared times k plus 2 squared out of 4. That's what we're aiming for. If we simplify this and get this expression, then we finished our proof. So we're going to add these together. We have k squared times k plus 1 squared plus 4 times k plus 1 cubed out of 4. Now you could multiply everything out, but I think there's a simple way to do it. I think we can factor out, since we have k plus 1 squared and k plus 1 cubed here, we could factor out a k plus 1 squared, and inside the brackets we'll have k squared plus 4 times k plus 1 all over 4. And next we can simplify what we have in the brackets here. That's k squared plus 4k plus 4. And this, what we have in the brackets over here, is actually, if we factor it, we get k plus 2 squared. And out of 4, and I think we're done. Yes, that is what we're trying to get. So that is the same as what we were trying to prove. So we can say now, therefore it's true for all n greater than or equal to 1. So that formula checks out for all n greater than or equal to 1. In our next example, we're going to prove this equation right here. And so let's start off with n equals 1. So we're going to have 1 over 2. Okay, actually we're going to have just one sum here. So that is 1 over 1 times 1 plus 1, which equals 1 over 2, or half. And if we look at this bit here, that's 1 over 1 plus 1, which equals half. So it is true for n equals 1. We're going to assume it's true for n equals k, some k greater than or equal to 1. So that means that 1 over 1 times 2 plus 1 over 2 times 3 plus dot 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 plus 1 over k times k plus 1 equals k over k plus 1. Alright, and then lastly we're going to show it's true for n equals k plus 1. Alright, so if we have n equals k plus 1, we're going to do this sum, 1 over 1 times 2 plus 1 over 2 times 3 plus, we're going to have 1 over k times k plus 1 as the second last term. The last term is 1 over k plus 1 times k plus 2. Alright, so we're going to get, actually we can substitute right away, because we know that this here is going to be equal to, that's going to be equal to k out of k plus 1, because that was our assumption. And we're going to have plus 1 over k plus 1 times k plus 2 here. And we're going to simplify this expression. We can multiply by k plus 2. And we will get k times k plus 2 plus 1 out of k plus 1 times k plus 2, which equals k squared plus 2k plus 1 out of k plus 1 times k plus 2, which equals, if we factor the numerator, we'll have k plus 1 squared out of k plus 1 times k plus 2. And then we can simplify here. We can cancel a k plus 1 and a k plus 1. We'll have a k plus 1 on the numerator and a k plus 2 in the denominator, which of course is equal to k plus 1 out of k plus 1 plus 1. So we've shown that it is true for k plus 1. So therefore it's true for all n greater than or equal to 1.